Well, here is part 2 of the review for exam 1. This has been a biting problem. Many people have written to me on discussion board and otherwise telling me that this problem is tough. And indeed, this problem is the toughest. And thank you for trying. And here it is. Oh, you should not see it as... see it in parts. I had to make that diagram a little bit more neat for you to see, so I just covered all that up. As you can see, just left the basket there. Okay, that distance is 4.57 meter. The height of the basket 3.07. The height from which it throws is 2.58. The velocity at which it throws, let's take it as v naught, it's given as 7.95. so the two components are v naught cos theta and v naught sin theta. And to find the vertical displacement, delta y, we use this equation. I'm moving fast because we have used this so many times. V naught sin theta t minus 1/2 gt squared. And to find the horizontal displacement, we use v naught cos theta time multiplied by the time. Okay, from here you can make time the subject. We'll call that equation 1 and then we'll call this equation 2. So we'll substitute the value of t from 2 into 1. Okay, actually we're substituting from 2 into 1. So that will become delta y v naught sin theta t. Instead of t, we'll write the whole thing. Delta x by v naught cos theta minus 1/2 g. And when you have t squared, you can write delta x by v naught cos theta the whole square. So you got to square every quantity in there. Okay, that is delta y. V naught gets cancelled. Sin theta by cos theta is tan theta. And then you have minus g delta x squared. There's a 2 v naught squared cos squared theta. Okay, but now remember that unless we use 1 plus tan squared theta is equal to 1 by cos squared theta, this problem cannot be worked out. So obviously that is why many of you have not been able to proceed. So in place of 1 by cos squared theta, actually there's 1 by 1 here, you can. So we're going to substitute that as 1 plus tan squared theta in the next step, as you can see. Tan theta times delta x, no change there, minus g delta x squared by 2 v naught squared, no change. But in place of 1 by cos squared theta, I'm going to put 1 plus tan squared theta. Now you have an equation in which you only have tan theta. Substitute delta y is 0.47. You know why? Because it is 3.07 minus 2.58. That is the vertical displacement of the ball. Tan theta, delta x is 4.57. G, then delta x. 4.57 squared by 2 times velocity is 7.95 squared. And then 1 plus tan squared theta. Okay, rearrange this. In the next step, I just want to calculate what this is and show you. Okay, no other changes. I get that as 1.62. 1 plus tan squared theta. I want to collect the terms all to one side, but before that I want to distribute the last one there. So you get 1.62 times 1 is negative 1.62, and then the next term will be negative. Well, there's a lot of math here and you got to be really careful. Okay, and that one becomes 1.62 tan squared theta. Just bringing all of them to one side. Be careful about the sign. I will get 2.09 because it's 1.62 plus 0.47. So I've collected all the terms. That looks like a quadratic equation to me. What do you say? But the problem is where you see tan squared theta, we'll try to take it as, we'll take tan theta as x. So this becomes 1.62x squared minus 4.57x plus 2.09 is equal to 0, where I have taken x to be equal to tan theta. Now, for a quadratic equation, the solution is minus b plus or minus square root b squared minus 4ac by 2a. B is negative 4.57, so just be careful to look at it. You really have to be strong in your math. 4 times A is 1.62, C is 2.09, divided by 2 times 1.62. When you calculate that carefully, you would get 2.25. So tan theta is 2.25. Theta is tan inverse of 2.25, which gives you 66 degrees. Kudos for even having tried to do this problem. This was tough because you had to know that 1 plus tan squared theta was 1 by cos squared theta. At least you had to think in those lines. Thank you for those who kept trying. Good luck. Expect more of review parts to come up there.